Covering the manual flight display with the Matrice 300 RTK and H20 series using the DJI Pilot app. So one thing to remember here, basics remain. Material we previously covered with the Pilot app and the Mavic 2 Enterprise series remains on the display for the most part. We're going to focus on the interface with the H20T. The H20 is pretty much the same, except it doesn't have a thermal camera, so there's no option for it there. But most of the functions and items on the screen are still going to be there because they don't necessarily require the thermal camera. So, probably looks familiar from when we talked about the Pilot app with the Mavic 2 Enterprise Dual. Just circling it, quick review around the horn here. DJI icon in the top left to go back to our main menu. We have our aircraft status, all of the different menus. We can click on these items here to go to, such as our vision system, RC signal strength, video transmission, battery, we have our current mode, DJI AirSense, camera settings on the right side, our map on the bottom left. So switching over to our Matrice 300 RTK, you can see all of these items are still here. Current camera settings, notifications, map, same photo video toggle button, etc. Moving in to shot of the Mavic 2 Enterprise Dual here, we can see we have our zoom slider on the right side, different camera views we could select on the left side, current remaining battery life, and then we have some key telemetry data, such as distance from the home point and our height on the bottom. And that looks similar here with the Matrice 300 RTK, but you can see one of the major changes is the navigation display is going to display that information in a slightly different way, which we find to be a bit more ideal for pilots, and that's enabled by the optical sensing system and some of the different features that come along with this aircraft. So you can also see in the top left numerous icons for items the Matrice series and the Matrice 300 RTK series has. With the improved transmission system and the advanced features, these settings are added in. When we're comparing this to the Mavic 2 Enterprise Dual as well, the Mavic 2 Enterprise Dual only has one payload, right? It was either the Dual or the Zoom. When we are moving into the Matrice series now with the 300, we have the built-in FPV camera, so that's one camera feed coming in. We can mount multiple payloads, so then that's additional feeds coming in. So with these multiple video feeds, it gives us the ability as the pilot to switch which video feed we're viewing. So you can see right now, currently viewing the FPV video feed, and you know that because you don't have a bunch of icons here in the top left. There's no option to take a photo or a video. We can see our navigation display built for the pilot kind of takes a page out of the manned aviation book like we talked about. We have our altitude, speed, etc., which we'll get into here in just a second. If you want to switch over to the gimbal, which is the H20T in this case, we'd click on the video feed in the bottom right, switching over. And now you can see the FPV video feed is in the bottom right. If we wanted to change which payload is the second video feed, so for example, Z30, XT2, and FPV, then we have three. We can only pick 2 out of the 3 at a time with a single controller and 3 total between 2 controllers. You do that with this button right here. On just below that is a minimize button, and that can minimize a second payload feed if you had something on your display that you wanted to see in that area. So, touching on it a bit, but our FPV view, that camera is fixed within the drone. There's no 3-axis gimbal to keep it steady on the horizon like our H20T. So you can see the drone here is really banked to the left. So our FPV camera, right, the horizon is almost looks like, you know, a 45-degree angle here. But our H20T, right, it's nice and level. And you can even see it in the bottom right of there, that image too, right, because that 3-axis gimbal is able to keep the camera steady on the horizon. Our FPV camera is more of a true life experience of the drone's current relation to the horizon there, which you can see that bar going across. It's also a very wide fisheye lens with the FPV camera to give you more situational awareness, and it's built with the idea of the pilot in mind. So this navigation display here we talked about, you're going to see as the FPV pilot, current aircraft speed, the wind speed and direction, that's in relation to the aircraft. So the wind isn't coming from the northeast, never eat shredded wheat, now that's right. But it's coming from the front right of the aircraft. And that's judged by the aircraft in the air, the correction it has to make. So 10.1 miles an hour. In this case, we are in Imperial. Moving over to the right side, we have the altitude, and that's between the aircraft and the home point, the aircraft's vertical speed, and absolute altitude for the aircraft. You can also see right there on our right side when we're looking at altitude, we have our return to home. So right in this case, it's at 90 feet, 90 meters, like whatever units you're using. So you can see it's right above 82 in that sense when we're looking at our display. Touched on this, but just showing you a visual representation, right, of the drone. We're moving to the left here, so right, the left side of the aircraft is going to be a bit lower, so that's why our horizon line shifted a little bit to the left, by a bit of an exaggeration there with the drone there, but you get the idea. And then we also have our flight path vector. So if we kept the current control inputs, that's where our drone is going to end up. On the bottom here, display shows current gimbal orientations. So yellow for gimbal 1, blue for gimbal 2, purple if you have a third gimbal going. Those pentagons along the display. So we can see our current drone heading at 340 degrees, right next to north. And then we can see gimbal 1 in this case is pointed just to the right on the display when we're looking at our drone's orientation. That's always going to be in the front here. The degree up there will change if we yaw our drone to the left and the right, but this is always going to be drone facing forward here. We can see the horizontal distance between the aircraft and the home point. So in this case, the aircraft is to the back and the left of the drone. And then the flight path vector will also show on this display here. Getting into the horizontal obstacle avoidance here, you can see that also pops up in the display. Talked about how you can set this in the obstacle sensing settings within our detailed settings menu. And the key points to remember here is any detection shown within the circle is going to be within 52 feet of the aircraft horizontally. Anything shown on the outside, like we show here in the next slide, is a detection that's greater than 52 feet away. The detection is green because it's greater than our warning distance. Remember, warning distance yellow, braking distance red, and then shows as green. So if we had a detection here within 52 feet, greater than the warning distance, so say maybe we're at 40 feet here, it'd show up as green on our navigation display there. The detection now in the warning distance and less than 52 feet away, so it's showing up as yellow within the circle there. And then finally, we can see the braking system coming into play here as the detection shows up as red. And if we're trying to fly the aircraft forward here, since it's reached the braking distance, it's going to stop, and even if pushing that right stick forward, it is not going to do so. If you want to get closer to the object, you could turn off obstacle sensing or adjust that distance down to a lower number. Vertical obstacle avoidance here, we can see on the left side, same idea, yellow warning distance, red braking distance. It also shows that within relation to our navigation display. You can see vertical obstacle gives you 20 feet, 5.5 feet there when it's showing that detection there. So good, check of understanding here, right? Our altitude is 60 feet because that is compared to our home point. That doesn't necessarily mean above ground level that we're at 60 feet in this current juncture. So based on the downward vision system, the first obstacle the drone would encounter would be at 73 feet below the drone in this case. H20T display, great tutorial in app. We'll just review here really quick, but we have our zoom setting bar on the right side, tells you which camera is currently being used in the light green in the middle and what the zoom times is. So wide is only one time, but when we switch over to zoom or IR, we're going to be able to increase that zoom. You can click on the button icons on the left side to switch to the IR, the zoom camera of the H20T. If you have the H20, the IR option is just not going to be there, unfortunately. And then zoom camera field of view here is really a great feature. So we're in our wide view, it shows exactly what the zoom camera is looking at. So you can see here, when we zoom from 2 times to 5 times, the zoom is going to get smaller. That zoom field of view, as what the zoom camera is looking at, changes. Here's an example of it. Wide view, switch over to the zoom view. It's showing exactly what is inside that green box. So very useful in a scenario where you do want to utilize the zoom camera, but can quickly switch over to a wide camera to see exactly what you're looking at and where that's located. Some of the icons you're going to see on the display, if you're using the laser rangefinder without one of the intelligent features, it's just going to show up as red. If you're showing the laser rangefinder when smart tracking, it's going to show up as green. The pinpoint is going to be a green diamond, and then the home point, which we've seen before, is the yellow H in the circle. So example here, laser rangefinder, you can see it's showing up as red. It also shows up on our navigation display. It's pointed directly in front of the aircraft. If we swung our gimbal around to the right side, that laser rangefinder would also follow that, as that's within the H20T payload. And we can also see the current distance there on our display of the aircraft being 35 feet away from what the laser rangefinder is currently focused on. Smart tracking here, you can see it has now turned green. Once again, we have a distance away, 1,756 feet, really utilizing the zoom capability of the payload here. We can see once again it is directly in front of the aircraft, and we can see our current payload situation is set to follow mode, so it's set to be directly in front of the aircraft. And we'll get into that definitely in more when we talk about manual flight functions and these intelligent functions later on. But for now, just in regards to the display, when we're smart tracking, laser rangefinder indicator is going to show as green, both on the display and the bottom here. Pinpoint, when we drop a pinpoint, it's going to show up as a green diamond. You can see right now it is showing up on the left side of the display, because based on our navigation display, we'd have to turn the camera to the left in order to see it, because it's situated to the left of the drone here, 37 feet away. And then with the home point, same idea. The home point is to the right of the drone, so we'd have to turn to the right to see that in the live camera feed, 24 feet away. So hopefully that helps you understand the display a bit more. We're going to get into these manual flight functions more, really display, make more sense when we get into that in regards to pinpoint and smart track, but hopefully that helps you understand what we're seeing overall. Thanks.